Hi, a knapsack problem. This is a well-known problem. First of all, we will know about the problem, then we will see how it can be solved, and then we'll also understand how greedy method is applicable here, and it is following greedy method. Let us understand this problem. See here, some objects are given. 1 to 7 objects are given. Every object is having some profit associated with it, and every object is having some weight. So objects are there, every object is having some profit and every object is having weight. Okay, weight we understand. What is this profit? See, there is a bag given here. That bag is called as knapsack. The bag capacity is 15. These are 7 objects. Bag capacity is 15. There is a bag whose capacity is 15, let us say kg. Okay, it can be kgs also, pound also, it can be anything. So I am assuming it as kg. Now what we have to do is, we have to fill this bag with these objects, and we will carry this bag to a different place and we will sell away these objects. We get that profit. So that profit is the gain that you get by transferring these objects to some location. So for transferring, you have to carry them in this container or bag. So I can also call this knapsack as container. This is a bag or knapsack. I can also call it as container. So the problem is a container loading problem. So we find this type of problems in daily life. A lot of goods are transported daily from one place to another place. Now the problem is about filling of that container with the objects. When it becomes a problem, if you have the objects whose total weight is more than the capacity of the container or a bag, if you have less, all can fit in, then no problem at all. If you have the objects more in number, their weight is greater than the capacity of a bag, then it is a problem. So already we have some objects here. So I have to fill this bag with these objects such that the profit is maximized. Profit is maximized. So this is a optimization problem and it is a maximization problem. Maximization problem. Can we follow greedy method? Yes, we can follow greedy method on optimization problem if it is suitable. Next thing, what is the constraint here? The total objects included here in the bag, their total weight should be less than or equal to 15 kg. This is a constraint. So I can give various solutions. I can say that just put only one object and take it. It's not maximum. I'll say all cannot fit in. It's not feasible. So it cannot be optimal. So there can be many solutions. You can say take this, that and all and fill this one. But we want maximum result. That's it. For a problem, there can be many solutions, but those solutions which are giving, the solution which is giving maximum result is an optimal solution. Let us see how to solve this one. See, what I am going to do is, for these objects, I am going to include them. So I will write down whether the object is going to be included or not included, or how much it is included. I will write down here X values. So here I will be writing X1 or X2 or X3, right? X values I will be writing. So this X value can be either 0 to 1. This X can be from 0 to 1. So it means I can also take fractions. Yes. So now listen one thing very carefully. This knapsack problem is for those objects which are divisible. I have something of 5 kg means I need not take all 5 kg. I can just take 2 kg also, 1 kg also. So these objects can be divided. So what type of objects? If I take an example, these may be vegetables. 7 kg of potatoes, 5 kg of tomatoes, something. So instead of taking 5 kg, I can take 2 kg also. Means it can be divided. Yes. So this is not about those objects which are indivisible. Let us say 5 kg grinder, mixer, 7 kg washing machine. It cannot be divided. It cannot take half of that washing machine. So I have to take the full one. So here I can take the fraction of an object also. So that's how whatever I am including, that can be a fraction starting from 0 to 1. Now let us see how to include these objects in the bag. What should be my criteria, method for including them in the bag? You may be saying that this is giving highest profit, take that one first. Yes, that is giving highest profit, take that one first. But I can say that first fill the bag with smaller things so that I can get more and more things in the bag and I can make more profit. More things you carry, more will be the profit. So I prefer take these objects first with 1 kg weight or smaller weights. So your idea is also good. Take the maximum profit one, and my idea is also good. Take the smaller weights one so that I can have more objects. But what is the right method? I should select the objects which is having highest profit by weight. Is 18 is the profit. So I say that 18 bucks is the profit. Then that profit is for 4 kg. It's not for 1 kg, it's for 4 kg. So per kg how much? So that's it. We should select the objects who are having highest profit by weight. Per kg, whoever is highest, that I should take. So I should calculate this one. So I will calculate profit by weight for all these objects. So this is 5 and this is 1.3 and this will be 3. This is 1 and this is 6 and 18 by 4 is 4.5 and this is 3. Now I have these profits and weights of all those objects. Yes, this is the right selection procedure for the object. So the object should be selected based on their profit by weight. So the one who is having highest profit by weight, that I should put it in the bag first. Alright, now this is the greedy method. Let us see what the greedy method is doing. I was explaining you the problem so far. Then I said on what basis I should select this. Now we decided that we will select the object based on their profit by weight. This is our procedure. Now greedy method says that first you decide how you are going to select the input. Then go on selecting the input one by one. So we already selected the method. We are going to select them by profit by weight. Now we will be going on including them one by one. So which object I should include first in the bag? The highest profit by weight, that is fifth object. So I will include this whole thing. So now this is 15 kg, right? So 15 minus how many kg this object is? 1. So now remaining 14 kgs I have. So I have included that fifth object in the bag and I got the full profit 6. Now who is next? This one. I will select this one also, this whole, all 2 kgs I will take. So this is 14 minus 2 kgs. Now I have 12 kgs remaining in the bag. Now which is the next objects? So this is the highest, then this is the next highest, this is the third highest. I will select this object also completely full. So full means all 4 kgs I will include. This is weight, 4 kgs I will include. So this is 12 minus 4 is 8 kg. 8 kg I have included, right? So 8 kgs are remaining. Now which is the next one? So I have 3, these are 2. I can pick up any one. So I will select this object. So this is how many kgs now? This is 5 kgs. Don't look at the weight. Don't look at the weight. I am selecting this one. This is giving profit by weight. So this is 5 kg and I'll be getting 15 profit. So the profit is same only. For both of them it is same. So I'll select this. So how many kgs are gone? 5 kgs. So 8 minus 5, I am left with just 3 kgs in the bag. Now next is which one? This one. So I will take this whole thing. So how many kg? 1 kg. So 3 kgs are there minus 1. Now I am left with 2 kg. Now which is the next one giving the profit? So this one. So I will include this. But this is how many kg? 3 kg. How much I have there? I have only 2 kgs remaining. So can I include all these 3 kgs there? No. I will be including only 2 kg there. So this is 2 minus 2. 0 it will become, but from this one I am not taking the full object, I am just taking 2 kg out of 3. So this is 2 by 3. So I am taking the fraction of this object, you said. Already I told you that these objects are divisible, so I am taking 2 kgs out of that. And what about this? This is not included. So I have a solution for this problem, and this is the solution. This shows how I am going to include the objects, which objects I should include so that I get the maximum profit. Now I have to calculate the profit and find out how much it is. I have just written here the values from 0 to 1. Now I will see total how much profit I get, and I will also verify the weight that I am getting 15 kg only or not. Here I write these values. 1 with weight 1 into 2 plus 2 by 3 into this weight 3 plus 1 into 5 plus 0 into 7 plus 1 into 1 plus 1 into 4 kg plus 1 into 1 kg. If I take this is 2 plus this is 2 plus 5 plus 0 plus 1 plus 4 plus 1. So this is 9, 10, 14 plus 1, 15. So yes, the total weight is 15 only. See, these are the x values. This is from 0 to 1, so that I am multiplying with weights. So what is this? Sum of the xi into weight I, and that is less than equal to 15. So I have found out the total weight. I was just subtracting, now I am just verifying it. Now let me know the profit. So for profit also, what I will do is 1 into 10, 1 into 10 plus 2 by 3 into 5, 2 by 3 into 5 plus 1 into 15 plus 0 into 7. I will avoid writing it. Then 1 into 6, 1 into 6 plus 1 into 18, 1 into 18 plus 1 into 3, 1 into 3. This is the profit. So this is nothing but summation of xi into pi. Every x value is multiplied with profit. So this is showing how much quantity I am taking, x. Now what is this total equal to? This is 10 plus 2 into 1.3 plus 15 plus 6 plus 18 plus 3. So this is 54.6. So that's it. Our total profit is 54.6 and the total weight is 15. Once again, I'll show you something here. See, these objects are given. Then what is the constraint given in the problem? The constraint is what? Sum of the weights of the objects included in the bag should be less than equal to capacity of the bag. Yes, we have done it. See, total weight should be less than equal to 15, and this is satisfied. This is the constraint given in the problem. So we have taken that solution which is satisfying the constraint. Yes, this solution is satisfying. So this is feasible. And objective is what? Objective is sum of the weights, profits of the objects that are included should be maximum. This is the objective of a problem, and we have achieved both. Now quickly I will explain you how we have followed the greedy method. Once again I am explaining you. See, the objects are given and the bag is given. We have to include these objects in the bag such that the profit is maximum, but the total weight should not exceed that one. So we have to select some objects such that we guarantee that we are getting maximum profit. So we have decided the criteria of selection. Have we tried this object? No. Without trying, how you can say that that is the best one? Because the method we followed is best one. The method we followed is best one, that we selected those objects whose profit by weight is higher, and definitely whoever per kg value is greater, that will give you the maximum profit. So that's all about knapsack problem. There is one more problem called 0-1 knapsack problem. That is different from this one. How it is different? Here fraction of an object is allowed, but there indivisible objects, fractions are not allowed. So this is container loading with vegetables or fruits like this, which are divisible things. Anything that is divisible. And 0-1 knapsack problem will be container loading with indivisible thing. Either you include that whole thing or you don't include at all. So you cannot take the part of it. So that's all. So I'll be making videos for all the topics that are there in greedy, and then I'll move on to dynamic programming and so on. So I'll be covering the entire syllabus, what all the topics are there in the syllabus. Okay, thank you for watching.